My name is Pim. I'm here today with Robin. Robin is one of our founding engineers, and I'm the founder of STRM Privacy. We are building a product that makes it very easy to be confident about privacy and quickly launch data pipelines, and we think that has a lot of advantages. Today, we'll take you through sort of the story and the learnings that we have. We hope you'll walk away with a few very concrete points in how you can build privacy by design or bring privacy by design to you or to your data. It is not, yeah, there we are. So first, the story, how we actually got to learn that. Then we'll dive into a architecture as an example, which is how we are built. And then there's a quick demo and a solution that we think brings privacy by design to data. So I'd like to take you back to May 25th, 2018. So we're from Europe. This is a key date if you're in data in Europe, because it's the implementation date of GDPR. It became effective as of now. We were at a large e-commerce marketplace, building the streaming data platform and applied machine learning. And we weren't too worried about privacy. We were just building cool stuff. But this came up. And then there was a lawyer 7 weeks in advance that told us, you can't do recommendations anymore. And no recommendations at a marketplace is sort of painful. So that got our attention, got senior management attention as well. And there was the start of 7 weeks of trying to reprocess 18 years of data that didn't even fit into the data center. It's a story for another talk, actually. It was also the start of learning how to translate a very vague legislation into very concrete data system implications. This is 4 years ago, almost 4 years ago. And if you look at the state of privacy or the cost of privacy right now, we haven't gotten really far. The sort of true implications of privacy are right now that it takes a lot of coordination to make sure systems are privacy ready or privacy safe. I think we're all worried about the utility that we can keep in data. We have a fun talk right after ours about how to retain the utility. But there's sort of like this ghost, if you need to do privacy, you will lose the usefulness of your data. We think that's not true, but that's still what we run into quite a lot. And because there's such a big gap between the policy perspective and the data and engineering perspective, the real responsibility, like, does your lawyer understand data? Probably not quite. They can draft agreements and they can write a lot of stuff, but it's different from building it inside data. So like Atlas, who carried the world on his shoulders, data teams carry the real responsibility for privacy. This means that in practice, there's basically no standard. There is a standard which is employed by many vendors and I think inside many organizations, and that's just restricting access. Like, okay, oh, you have role I, well, you cannot access a specific column, and that's how we deal with privacy. But actually, that's way too late. It's not way too late, or it is not just way too late from the policy perspective, it's way too late in general, because privacy starts at the point of data collection. So these are basically sort of the 5 principles that we distilled in those 7 weeks of awesome learning about how to bring privacy by design to data. And the very first thing, I know there's quite some stuff going on about discovering data patterns, discovering data structure automatically. But when talking about privacy, you need to know what your data is. You need to make your structure very, very explicit. We call them data contracts. We'll get to that. The next point is what I already mentioned. Is okay, thinking about data privacy as soon as you have data is too late. You need to shift left. You need to shift to the point of data collection where data actually starts living, because, and this is a key concept in, I think, any privacy legislation anywhere around the world, you need to know what you can do with data. You need to know the purpose. Consent is a very simple example. Can I use this for marketing purposes? Can I use this for personalization purposes? Or perhaps I can't use it at all because I acquired the data point under some kind of legal grounds, like I need to fulfill a contract. So it's a very narrow definition of what you can do with data. You need to move it all the way to the beginning of your stack. The next problem comes if you don't know what your data is, then you also don't know what you need to do in terms of processing. So you need to apply the privacy transform before you do anything else. So we're not even talking data warehouses, we're just talking data collection, and immediately at that point, convert the data into useful data from the privacy perspective. You need to define purpose-bounded stream. So that is, I have this data point collected under a marketing purpose. So let's make sure that we can only use it for cases that fit that specific purpose. And because we have very complex stacks and we're running all sorts of tools, you need to make it interoperable and fast. So we're streaming based. That's not because we're religious about streaming, we are, but that's not the reason. It's because if you remove any latency constraints right at the beginning, you can run any system downstream, anything you still have, be it batch, be it another streaming pipeline. It doesn't matter, it gets agnostic. So let's break that down. Those are the 5 principles, diving into the technical point of view. The first step, like we said, this is basically a process step. This is you, the data team, agreeing with the legal team or someone involved with policy, how you will actually use and collect the data and how it should be processed. And like I said, that takes data structure, explicit data structure. We call them data contracts. A data contract falls apart is a very simple concept. We have a shape, which is what we all do, a schema registry. Okay, this is field 1, field 2, field 3, and they have specific types. But it's also a description of the privacy implications of each field. So a very simple example would be a user ID. If I'm running analytics, I don't need user ID per se. I might want to retain some kind of pattern, so I need to apply a masking function to the field of user ID for specific purposes. And in the data contract, the field has a sort of level, a purpose level that is described very, very concise, very strictly in how it should be transformed later on. So this is just simply the agreement stage. You can register these contracts, and that's the start. That's why you think about what are the privacy implications of what we do. If we move on, and Robin will now take over for the architecture and a small demo as well, then the question becomes, once we have that, once we have this description, once we have the definition, how to actually do the processing.
Thanks, Pim. Yeah, so I'll move on now to an example architecture on how to actually implement these principles that Pim just discussed. So what you see in this example architecture is it all starts with applications sending data. So these applications, they send data to a so-called gatekeeper. And this gatekeeper, the purpose of this gatekeeper is at first that it enforces the data contract that Pim just mentioned. Second, it does validations on the content of the events that are being sent. And lastly, it applies the anonymization to the sensitive data fields. The result of this process is a stream which is anonymized and can be used actually by anyone within your organization. So what happens if you want the de-anonymized form of the data? Well, then you can actually apply privacy transformations to get the original form of the data back. But you, of course, want to make distinction between the various levels. So a end user provided consent for his data to be used in a specific purpose, and you want to respect that. So you will only get the de-anonymized versions of the data for which the end user provided the consent. And that's because this consent is actually embedded into the events themselves. So the end result here is that we have purpose-binded interfaces which can be exposed to data consumers in various ways. Here you see a WebSocket, for example, at the top, which we'll see in our demo. This, of course, is all nice, but we do need good tooling around this. And that's why we offer a web interface and a good CLI to interact and manage these streams. And of course, like Pim already mentioned, you want to be able to use your existing data stack. And that's why we integrate with many of the tools you'll probably know and already love. So let's not try to replace that. Moving on to the demo. So the purpose of the demo is that we do visualizations in real time based on these privacy streams. So the stream that I just mentioned in the architecture, we're going to use that actually to do a real-time visualization. What we did is we took a data set from Kaggle of a large Spanish bank. And what we did at first was to create a data contract on this data. The second part is that we created a simulator that replays over this data and actually simulates a live clickstream. And the last part is actually the visualization itself. Note that all this is done using the anonymized form of the data, so we still respect the end user consent. Well, to not test the demo gods, we made a video, and what we do at the beginning is actually create this data contract. So the data contract is composed of two components, of which the first one is the shape, the schema, and the second one is the contract, which defines the sensitive data fields, the PII fields. It does more, but the purpose of this demo is aimed at that part. So while we wait up for that to be finished, we can also inspect it. And actually, it's tied directly to the schema. So together, it makes up a full data contract. Here you can also see the sensitive data fields mentioned under PII fields. And the last part here is that we need to create a stream to which we can send events. This will present us with credentials, and these credentials can then be used for our simulator to actually start sending data, what you see over here. Next step is actually viewing the data via the WebSocket interface meant for debug purposes, and we see data flowing through. Important part here is that not everything is anonymized. Only the fields that are mentioned in the data contract are anonymized. We can view a single event, and at the top we see meta information, which actually defines the consent provided for this single event. This part is actually another representation of the data, a simplified version, and you see everything passing by. Okay, nice. Next step is that we actually create pairs of data which represent page transitions between web pages on the Spanish bank site. Then we can do counts on these pairs to actually see and visualize these page transitions and present them in a visual representation shown on the left, a force-directed graph here. Okay, what do you have with that? Well, you can see funnels on your website. So you can actually see how people move on your website. And the end goal here is, for example, to actually predict what the next page will be to help your customers on your website to move to the path that they need to go to faster. That wraps up the demo. Note that it's done using the anonymized form of the data, so we really respect the end user consent. Pim, back to you.
Yeah, thanks. So that's, we think, a pretty cool use case because it allows you to expose, for instance, a real-time next best action model to users that you don't necessarily need to know anything about or have consent on. That's the cool thing about anonymization or de-identification. You can actually use the data for different purposes than you obtained it. And that's just one of the use cases that we see. So this would be basically an input feature to a model that you would build and expose yourself. There's tons of other stuff that we see users and customers working on. Operational analytics in mobility is a cool one, like something like scooters. A location data point is completely insensitive, but if you have a day of data, it's suddenly incredibly sensitive because it could expose where someone lives and where someone works. That's a very easy case one identification problem. There's a lot of health applications. When does someone go into cardiac arrest? You would like to know that in a certain time window. Thank you. So that really helps to process all the data and use immediately. And one of the key things, and this is actually what we we started to solve a technical problem, and we're discovering that basically privacy is a process problem more than just technology. That is that it helps to structure the privacy discussions inside companies. So you put the legal and the data team at a table, they agree on what can be done with data, and that's the only discussion you're having. The rest is just build and expose what you would like to build and expose. So the summary in terms of how to bring privacy by design to your data. Make sure you insert privacy before anything else. Encode the privacy policies through data contracts. align the privacy policies and the processing in one go, distribute what we call privacy stream purpose-driven interfaces, and you can do this all in real time if necessary. But if you start with real time, it's easy to go batch. That's it. Thank you.